So today we're going to talk about strings and lists. So we've already been working with strings a little bit. We've been working with the type string when we use text. And so let's think about strings in a slightly new way. Strings are a sequence of single characters. For example, we could create a variable band, which is equal to the Beatles. Remember, we use double quotes or single quotes to indicate that a value is a string literal. Now, what if I just wanted to access a single letter within this sequence? Well, Python allows us to do that. So for example, we would spell out the space Beatles as a single string, and each position in the string is assigned a value, an index, and this is true of all sequences, strings or lists in Python. In fact, any programming language has these index numbers, these positive index numbers, 0 through 10 in this case. So the length of our string is 11, but the index numbers start at 0. This is for historical reasons in computer science when we used to access things in memory, and we would store the location in memory and then what the offset of spaces it would be. So we always start lists in computer science at 0 now. And so we start at 0, we go up through but not including the length of 10. So you might start to see a pattern here because the range function did the same thing. So if I want to access just a portion of the string, I can access single elements, or I can even access a range. And the way I do that is with what's called the substring or splice operator, which are the square braces. And these are literal, they're not optional. The syntax is the name of the string, square brace, some kind of integer. It doesn't have to be an integer literal. It can be a variable or expression that evaluates to an integer value. If the integer is a positive value, it's the index of the character. If it's a negative value, it's also the index of the character, but instead of starting from left to right, the negative values start from right, go from right to left. So for example, if you put the name of a string or any sequence, like a list, with square braces 0 after it, it's going to return the first element. Likewise, you could put sequence and then -1 in square braces, and that's always going to give you the last element. Now, I mentioned that the positive values in Python, these hold true of any programming language that you'll encounter, starting at 0, going up through but not including the length of whatever sequence you're working with. However, negative values are specific to Python, and they are not supported as widely in as many programming languages. So let's take a look at a couple examples. So take a moment and run down this list of expressions and see if you can predict what letter, what value we're going to see. So if I have a variable band equals the Beatles, my string literal, what's going to be the result if I typed in band? I use the word sub, so sub 0 describes what's in those square braces. So band sub 0, what is that going to be? Take a moment and think of it for yourself. So if we look up here at the 0 index, we see it's below T, the first letter. So that result is going to be T. How about band 3? If you said space, you're correct. What about band length of band? Well, the length of band is 11. There is no index value 11, so it's actually it's going to give you an error that you have what's called an index out of bounds error. There is no index 11. It is out of bounds of the accepted indices of 0 through 10. And then band length of band -1, that does give us 10. That gives us a valid index. If you said S, you are correct. And finally, band of -1. Remember, the positive indexes start at the left and go to the right, and the negative indexes start all the way at the right and go to the left. So band -1 is going to also give us the letter S. Okay, and remember, these are strings, single character strings. Now, what if we want to select more than one letter within a string? Not all of the string, but part of the string. We can do that with the colon in between our square braces, and that allows us to select a substring of one or more characters. So for example, x:y gives us a subsequence starting at x and going up through but not including y. So it includes y minus 1. X colon is going to start at x and go until the end. Colon y is going to start at the beginning at index 0 and go up through but not including y. And to avoid errors, the position of x must be before the position of y in the sequence. However, it just has to be before it in the sequence. It doesn't matter if it's before it numerically. So you can use positive, you can mix positive and negative index values in here. There's a number of ways that you can actually get the whole sequence at once. If you trivially put a colon inside of a square brace, you'll get the whole sequence. Now you might ask, what would be the point? Why would I want the whole sequence, and why wouldn't I just use the original string? Well, what if you wanted to make a copy of a string or a list? This is the way you can go about doing that. And so 0 colon length of the sequence will give you the whole string, colon length, and 0 colon. All 4 of these will generate the whole sequence over again, because yes, we're talking about strings right now, but these same rules apply to any sequence, including lists, files, any type of sequential data in Python. Okay. So let's look at an example. Here we have a file name, which we've stored in a variable called file. File equals program.py. And we have the index values, 0 through 9, because the length is 10. So let's try and predict a couple more of these expressions using the colon this time instead of single characters. So if I've got file 0 colon, what will be my result? If you said the whole string program.py, then you are correct. How about 0 colon 2? Is it PR or PRO? Well, we're going to start at 0 and go up through, but not including 2, which means it's just going to be P and R. Colon 3, it's going to start at 0 and go up through, but not including 3, so that's actually going to give us pro. 8 colon, it's going to start here and go through the end, so that's going to give us pi. Negative 2 colon will do the same thing, because y is -1, p is -2. Very good. Now, one thing to note about strings, and this is different from other sequences in Python, strings are immutable. And what that means, you might recognize mutate, right? To mutate is to change. So strings are immutable, means you cannot change the value of a string once it's been created. Now, that's not to say you can't create new strings and store them in a variable. But once a string literal or a string has been created, it cannot be changed. It can only be adapted, like you can only reassign it. So for example, you can't change a single character in a string. So here we have a string and we're changing the first letter, 0. We want it to be capital S instead of whatever it was. We can't do that. We'll get errors in Python. However, we can change individual values of lists and other sequences. So this is something that's specific just to strings. And this is why all of the string functions we've been using so far have been fruitful, like .lower and .upper. They return a value that we then have to assign back to another string. So you can print out a string .upper, but if you want to use that string later, you'd have to say string equals string.upper. I highly recommend you try it. In contrast, lists are mutable. You can change the values of lists. So for example, if I have a list of single letters and I say list 1 is S, then I'm going to have a list of all S's. And so the list functions, which you may not have used yet, but which we're going to use now, are all void because they operate on the list underneath. Just one thing to note, functions and methods. Sometimes you might have heard me switch these words every once in a while, but predominantly we've been working with functions. Technically, there's two types of functions. There's functions and then there are methods. In what's called object-oriented programming, if you've heard of that term before, object-oriented functions are always called methods, and there's a reason, because methods are called on an object. So we have, or a variable, we've been actually using methods. I was calling them functions, but we've been using methods. The string methods you've been using, where you say string dot something, those are actually methods, not functions. Functions are built in, and you don't call them on anything. This includes the math functions, because you say math dot, but the math is a module name. It's like a path to get to the function. It's not a variable whose value you're using and you're applying the function on. So for example, length string, getting the length of a string is a function, but string.upper is a method. Some common string methods that we'll be working with, you might have already worked with, like center, count, ends with, find, is alpha, is digit, lower and upper. Some other things we might start working with: replace, split, strip, join, swap case. So join is really handy if you want to turn a list into a single string. One other piece to note now that we're dealing with strings is that sometimes we want to use special values in our string. So for example, let's say I'm creating a string with double quotes and I want to put a double quote inside of it. The way I do that is with a backslash. It's called escaping that character, or escaping that double quote. So when we want to add new lines into our string, we want to go on to the next line, we can use something called \n. If we want to indent the output that we're printing out to the screen, we can use tabs, \t. Again, if you're using quotes, we might need to escape them, only if we've used the same quote to indicate the string literal. So for example, if you want to put a double quote in your string, if you surround it with single quotes, then you're all good. But if you want to put double quotes and single quotes in your string, then you have to escape one of them. And similarly, if you want to put a backslash in your string, you have to escape that as well. So for example, to print a backslash, you must use quote 2 backslashes. And so this is how I would print out 2 backslashes. It would be 1, 2, 3, 4 of these here. 1, 2, 3, 4, there we go. And then these other backslashes are escaping the double quotes. Okay, so we talked about strings and how they're a sequence of characters. Lists are also just sequences of data elements. So for example, I could have a list of the days of the week. We start at 0, go up through, but not including the length. So we go up through 6 would be our indexes. We access these the exact same way we do with strings. The difference is that elements in a list, instead of being a single letter or a single character, can be any data type. And so in general, we have been working with sequences already. We've worked with strings, which are sequences of characters. We've worked with range, which is a generator function that generates a sequence of numbers. And in general, we commonly group a sequence of data together and then refer to them by one name, like days of the week, months of the year, or a shopping list. And that's where lists come in handy in Python. And we can represent this data using something called a list in Python. And it's very similar to arrays, if you've heard of that word before, in other programming languages. So just to give you some examples, we have the empty list, which is just empty square braces. We can list the days of the week. Again, everything goes inside square braces to indicate the list. So here are all my elements, my days of the week: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. I could have a list of floats. I could have a list of a bunch of different types, like Wheel of Fortune, 250, 1,000, bankrupt, and free play. And the syntax for lists is really no different from accessing a string.